Now, welcome back to my channel. Now we're going to continue. In the previous video, we derived the time-dependent Schrödinger equation. Now we're going to derive the time-independent Schrödinger equation. So we needed to start from the time-dependent Schrödinger equation. Then we proceed with the separation of variables. Then we proceed. So let us proceed. So we need to So this is the time dependent. Now we are needing to separate the variables and then we continue to the time independent. Separation of variables. So if I have this blank as constant square, the 2n of this one as a function of x and time. Now we have x and t. Now with the separation of variables, this one is equal to writing, let me first deal with this one. This is equal to one function of, because it is with respect to x, the function with respect to time is going to be taken out. Then I will have this phi as function of time times the total derivative now, because we have only x left of yes of this one squared squared. That is it. Now if I have the psi as a function of x and t, this one is equal to the function phi of t times function psi of x. And then also, yes, here it is also x and t. Now I have, if I have with respect to time, this one is equal to, because now it is with respect to time now, this x will be taken out as a constant, then I will have the function psi of x times total derivative of psi as a function of time, phi function of time with respect to time. Yes. So now I'm going to take these equations. This is equation 1. This is equation 2, and this is equation 3. I'm going to place them in my original equation. It will be minus this constant, the 2n times this one is equal to this. So it will be times this as a function of x over, yes, now this is done, plus u, potential energy, as a function of x, then times psi is this one as a function of time, times psi, which is equal to this one as constant, times this one, which is equal to psi of x times d phi is this vector time, is this vector time. So this is what we have. Now, To simplify my formula, my function, I am going to multiply both sides by multiply by multiply by this one and this one, both sides. Yes, now I'm so sorry, this one, it is the inverse. You multiply by 1 over sine x times 5 function of time. Both sides. Yes. Yes, now we have yes, now I will have minus h over 2 m as this one times 1 over sine x see this one then yes, this is total derivative. This one function of x yes plus u as a function of x times sine function of x c as function of time over sine x yes this one which is equal to I as constant times 1 over sine x 5t times d sine function of time d phi dt. Yes, times there is also here sine x. Yes. Okay, now you can see that this one can cancel with this one cancel with this one, and this one cancel with this one. This means that my equation is now reduced because I have now separated the variables. This left hand side is only having the variables as a function of x, because this one also can go with this one. We have only x here in this part, and here also have only t. So let us write it. This one times 1 over sine x, then d plus u as a function of time, which is equal to this one over this one, then d dt. Now we are almost done, but now what I'm going to do, because I still have this sine x on the denominator, it means simply I can multiply both sides by sine x. Then this will mean that I will have times sine x over sine x d squared sine x over d squared plus u and function of x, which is equal to I and sine x I'm so sorry, this step will come after one step again. Remember, if two functions, now, the function of x will only equal to the function of t. Sorry, this one is t. So this one is t. Will only the function of time is only equal to the function of x if all of these functions are equal to one constant. And in this context, this constant is the total energy of the system. So it means both of them are equal to a constant E. So which means now this left hand side is alone is equal to that E. This one is equal to that E. So now we can multiply both sides by side x. It will be now this one is equal to 1 sine x. Then it will be equal to this one equal to n times sine x and d sine x plus ux sine x, which is equal to e sine x. So this sine x, they can go together. Then we have minus d. This one is squared. D squared sine x dt squared dx squared, which is equal to no plus the potential energy of x times sine x, which is equal to e sine x. So this one is the time. This is the time independent Schrödinger equation. Time independent Schrödinger equation. So now the other part here, this right hand side also is equal to e. Here. Yes, the right hand side, I, this part is constant over q as a function of time, d dt. This one also is equal to that same constant e that we talked about. So actually this other part integrates integrates to the solution of the time-dependent Schrödinger equation, which is this one as function of this and time that is equal to x times e power minus et over h bar, the reduced part as constant. So this one now is the solution to the time-dependent Schrödinger equation. So now, guys, I have been deriving the Schrödinger equation we derived the time-dependent Schrödinger equation in the first video. If you have not watched it, you go and watch it. And then I also derived now the time-independent Schrödinger equation in this video.